Welcome to the channel, Infinite Exploit, where we learn and have fun. Let's get started and Brody, please don't forget to like, comment, and subscribe. Love you guys.
In this video, I'm going to show you how to get input from a user in C. So a lot of times in a C program, you'll be dealing with a lot of types of information. So a lot of times you'll be getting that information from the user. So we're going to go over how we can prompt the user for information and how we can store that information in a variable. So the first thing we want to do is we want to prompt them. So I say printf, and I say enter your favorite number. Now that we prompt them to enter their favorite number, I need to create a variable where they can store this input. So I'll call it int favnum, and I just declared the variable. I just telling C I want to use this variable, and it's going to be an integer. So I can use another function called scanf, and it's basically going to take that input, and I got to pass in, and it's going to read it. So it's going to %d, so I can have our placeholder for integer, and I want to put this my favnum variable, and so instead of just putting it like this, I had to put an ampersand in front of it. So this is going to be a pointer, and I'm going to talk about that a little later. So now we're going to printf your favorite number is, and do our placeholder, and do favnum, and semicolon. And let me go ahead and compile this, and then we'll test it. All right. So 7, your favorite number is 7. So that's how we'll take user input. That's how we get an integer. What if we want a double? So what I can do here is I could change this to a double, and I could change this to LF, and I do %F since we'll be doing a double. And all right, and I can do 5.5. All right, that's how we get a double right there. Okay, so how do we create a character? So if we want to do a character, let's do CHR and my grade. We want character, we do %C, and I say my grade, enter your grade, and your grade is, and let's compile this and run it. Let's see what we get. Let's say we didn't do good this year. I did F, your grade is F, okay? So if we're doing a string of characters, you also get a string of characters from the user. So let me go ahead and demonstrate that. So this is going to be a little bit different. So how we do it, let's call it, I'm going to call it my name, and I got to specify how many characters I'm going to store in here. So I'll do 30. So we're not going to be giving it any information right away because we don't know what the user's name is going to be. So we want to see how big we want this variable to be. So C can allocate enough memory. So I put 30. Okay, so that's enough for a name. So I'm gonna say enter your name. Now I can use, so I don't need this ampersand here. I can just do this. So let's try this. It doesn't like the naming convention. Let me just do name. All right, and see what this does. It's got to be lowercase. All right, terminal. Try to compile it. It compiles successfully. Now let's do this into my name, infinite. It should say your name is infinite. All right. Now, the only thing with scanf is, if I suppose I did a last name. So, for example, if I say infinite exploit, it's not saying exploit, right? It's only gonna grab the characters up to the first space. So that's kind of the problem with scanf. So we could modify scanf to take care of open spaces, but another function I want to show you we can use is fgets. It's similar to scanf, but it's going to be more general. It's going to grab the whole thing of text. It won't be able to store it inside an integer or a variable, but the first argument we want to give it is this name variable. Then we got to specify how many characters we want to give it. So this is going to limit the amount of characters um, that the user can input. So imagine if they try to put in thousands of characters and overflow the buffer. So that's what buffer overflows come from. So we do 30 because this is how many we can store here. And we're going to do standard input. All right. So it's going to do what scanf get. It's going to store this, and it's going to be able to store multiple words in here. So if I recompile it, I can do infinite exploit. It'll pull out here. So now we're going to talk about arrays in C. So a lot of times we'll be dealing with a bunch of data in C, and in order to control or manage this data, we want to have these variables. And so one thing I want to talk to you about is array. So we have a list of multiple elements. We want to go ahead. We don't want to create 100 different variables. Array is a data structure that can store a lot of different data. So it can store 100,000 uh, million of data, right? So it's going to be nice and neat and organized. And I'm going to tell you how to create it. So a variable and an array are very similar in it. So a variable is like a container that could contain some information, but array can contain a lot of information. So say we want to do, say we do, say I do char. This would be a character. I could do double number. I could do int. So that'd be integer. So if I say my numbers, and if I do an open and close bracket, this means, hey, see, I want to store a bunch of numbers. So I could do curly brackets. I can do, let's say 2, 4, 6, 8, 10. I could type out as many as I want, and I could store it inside this array. And the only thing limiting me is how many I can put in here, right? So a comma is going to separate every element in here. So this is the first element, second element, third element. And the thing is, these are considered indexes, right? And it counts like this. It'll be 0, 1, 2, 3, 4. So we access those elements starting with 0, right? So if I do print f, all right, %d, because it's integer, and I can do an open and close square bracket, and I want to do the index. So we say this the first one. So at 0, right? Then now when I save and run my program, it should print out 2. You see it? if I want to access this one, what would I put? If you said 4, that's right. So let me go and recompile, and it's gonna print 10 because that's an index 4, right? So I also can change. I can also change a number in the index. So, for example, what if I go my numbers, which is my variable, and I want to change the first one, so in that 0, and I want to change it to 3000, and I want to print that index 0 here. It's going to print 3000 instead of 2 because I've changed that first index. So let me go ahead and compile this, and you'll see. See, I can do it with float doubles. I can do it with float double, right? What if I don't want to put anything in my array, right? What if I want to do that, but I don't want to give it all this information? I can do this. I need to see how many elements this array can hold, right? I can actually do 10, and it can hold 10 elements, and I can start assigning values to it. So if I do, for example, my numbers 1 equal 10, and I could print that first element, but I do want to make sure it's an integer. So, all right, so it should be good now, and I compile, it prints 10. So you need to have to tell C how many elements an array can hold, because it's going to allocate this in memory, okay? Now, one thing we've been using in this course is strings. So what if I did like phrase, and I say, sorry, hello? This is considered an array, you know? So I want to talk about functions now, okay? This is a collection of code that performs a specific task. So you can take a bunch of code and you can put it inside of a function, and you can access that code and call that function so it can do that specific task. So I'm going to show you how to create one. So this is technically a function. This main function, right? It's sometimes some people call it method. It can be used interchangeably. So we're going to go outside of this, and I'm going to go ahead and do a function. So when we create it, we gotta give C a couple pieces of information. So the first thing, we want to tell them the return type of the function. So we're going to talk about return type here as well. It's the type of data that the function is going to return to the user. So the function can give information back to whoever calls it. So I'm going to do void. It means it's not going to return any information. That's the first thing you want to tell C. And I'm going to do, I'm going to say, I'm going to call it hi user, because it's going to say hi to the user. Open and close parentheses, open and close curly bracket. Anything that's in between these open and close curly brackets is code inside the function. So if I do printf and I say hello user, let's go ahead and run the program, and let's see. It didn't get printed out because we didn't call the function. We got to call it. So it means telling C, hey, call the code inside that function. So I got to call it. I can actually type out the name of the function and put it here. So let's recompile it. Yeah, so it looks like I'm getting an error here with this. Now, based off of how the code reads, we have our headers, pretty much our libraries that we import to help this program compile. but it goes into the main function. But for some reason, this isn't defined yet. It's not going to go down and come back up. So the compiler doesn't know about it yet. So let's move our function to the top, and then we can call it. Let's move it up here. That way we already have it created. Yeah, hello user, that's good. Let's save it. Let's recompile it now. Okay, compiled successfully. Let me clear screen really quick and let's run it. So it prints it now. So for example, what if we wanted to do, let's see, let's go inside this main function. And what if we want to do, just tell you how the order it does things. We do printf up top. Let me do semicolons. Got to make sure I have my syntax correct. Then let's do printf down low. So it should call this function. It's going top to bottom, okay? So let's save it, recompile it, and now let's run it. So up top, hello user, it pulled this line, and then down low. And I could put these on a new line, but that just shows how it runs. So we also, another thing we can do too with these functions is I can actually pass in a name, right? I could pass in a name here, and I could say, let's just say Timmy. So that way it should say, hello user Timmy. That's what it should say, right? Y'all know it's not. All right, so in this video, I'm going to talk about how a function can take a parameter. And anytime, so so one thing I could do with this function is I can give this function some information. I can give it the information to do different things. It's called a parameter. It's basically a value that we give to a function. So instead of this just saying hi user, what if we want to say hi to someone specifically? I could specify a parameter. So I could say char name. So it's going to take a string of input, and I could print this out. So if I go, so I give it a string. So when I call it, when I call Timmy, it'll be able to get print out. Okay. All right. So yeah, that looks good. So let me go ahead and compile it. Clear screen. Let's run it. So it goes up top. It looks up here for this function. It finds that the parameter is Timmy, and then it goes down here. So we're able to customize this. So so I can copy this and I can pass in different names. So it'll say hello to different people. I could say John, Billy. Let's recompile it. Let's see. All right. So what if we wanted to also get their age as well? I can do, right. I could say I could say hello, and I could say, let's see, could say you are %d because we're specifying integer, and %s because of string, and %d because we're specifying an integer there. And I'll do name, and then I'll do comma age. So like we said, this is the placeholder for the string name, and D is the placeholder for age. Okay. So I also got to give these ages as well. So if I say it's 20, 15, 65, right? It's gonna print out this as well. So I'm going and clear screen again. Let's recompile. So you can pass as many parameters as you want with these functions. You just have to make sure that you're passing a parameter that you're calling. Now, we're going to also talk about this right here, the return type. So I'm going to talk to you about return statements in C, and this will allow us to return information. So let me go ahead and clear this. So I'll give you a basic overview how we do this. So let's create a function that can cube a number. So what if we did 5 cube, right? That'll be like 5, right? Once we cube the number, it's going to give that value back. So whenever we're returning values, we need to put it above the function that we're calling. So this is the first function that execute. If I want to return a value, I need to put it above the main function. So let's define it. So first thing I want to tell C is what type of data I want to return. So we did the void return type. We weren't returning information. Now we want to return information. So let's do a double since we're going to be cubing a number. So we can do character and all this as well if we wanted to. So I do cube. I'm gonna have it accept one parameter, another double. I'm gonna create a variable. I'm gonna do double result equal to num times num times num. And only thing we need to do return this result is return. It's gonna break us out and it's gonna return this. Okay. Now we can call it down here. So I can do printf and %f because we're doing a double. And all right, let's see. So let me go ahead and compile this. Clear screen. And it cubes that, okay? Let's try it with another number. Let's try it with 3. All right. And I can also remove this right here. And I can actually do return like that. And it should do the same thing. So let's recompile it. And as you see, it works. Now, this actually breaks us out. So if I say print F and I say print me, this one never get touched because return keyword breaks us out of the function. Okay. So As you see, it doesn't show it up here. Now, we're doing the cube function above the main function. So if I tried to put this below here, the main method would be trying to call this function, but it doesn't know where it's at because we created it after here. So now I can do something to get around this. It's called a prototype. So if I were to, if I, so let me show you what it does right quick, so you can see what happens when I try to run it below the main function. So you see it gives that error conflicting, right? However, so what I can do, I can put it this function signature like this, and I can put it up here. I can do it below the main function now. Let's recompile. See, it works. Now let's talk about an if statement and see. So we can do this as far as it adds intelligence to our program, so that way, based off of conditions, it can do certain things. It's going to take two parameters, and it's going to tell which number is biggest. So that's what we're going to do here. So I'm going to do a function. It's going to return an integer. So integer num1. And now we're going to try to figure out is num1 or num2 is the biggest. So we're going to do integer, which is the result. Now we need to figure out which one is the biggest. So this is one of the best situations to use an if statement. So if it's true, we do one thing. If it's false, we do another thing. So we'll say if, inside of here, we need to specify the conditions. It's going to be a true or false condition, okay? So we're going to execute code inside of these curly brackets. So we can compare these. So if I say if num1 is greater than num2, then I want to do something. So I could say result equal to num1. So if it's not, I could just do else. So if it's false, I can have result equal to num2, and then I can return result. So in the main function, I wanna call this. So here I do printf, and since we're dealing with an integer, %d, and we call our function by the function name, right? And I'm going to pass in whichever two numbers. So I'm gonna give it a 10, and I'll give it 12. So 12 is the biggest, right? So all right, so we're gonna compile this program. Let's see here. All right, let's recompile it and let's test it. So it returned 12. So all right, let's make the first number bigger this time. Recompile, quit screen. So this is the basics of using if statements. So if this condition is true, we're gonna do this. If it's not, we're gonna print this. Okay. So this is the beginning. So let's make this a little bit more complex. What if we wanted to accept 3 parameters and then have the maximum? So we can add another parameter. I can say num3. Okay. Now we're going to need a more complex if statement. So how can we make this? We can also do if num1 is bigger than num2 and num2 is bigger than num3, then we know number 3 is the biggest. So if I do if, so if num1 is greater than or equal to num2, so I can use it's a logical operator. So it allows us to do another condition. So it allows us to check two things, right? So if both of these are true, if this is the case, I want to set the result equal to num1. So if this is true, we know num1 is the biggest. So if it's false, we want to see if num2 is the biggest. So I can do an else if. So it's saying if this is false, let's check another condition. So if num2 is greater than or equal to num1 and num2 is greater than or equal to num3, then we know number 2 is the biggest. And if this is false, then we're just going to say result equals num3. So we'll check this condition first. If this true, is num1. Then we check this condition. If it's true, then it's num2. And if that's false, then it's going to print num3. So we need to do 3 numbers now. So let's do 20. Let's see. Recompile it. And it say 20 is the biggest, okay? So now it's a couple other things we can do with these if statements. So we can also use or as well. So if we say, let's say if 4 is greater than 2 or 2 is greater than 5, only one of these two conditions will be true. So let's do true. Only one of these have to be true, right? Let's power this. So if I want to do equality, I can do just a check. Does 4 equal 5? We can use this as well. This means 4 is not equal to 5, right? So this should be true because they are not equal. So these are comparison operators. Because up here, we looked at both of these conditions have to be correct. This condition, and this condition. Then we looked at the or condition, right? We did the or condition with this, right? Now, I can also do this. If I can also do this, I can say, and it's going to negate. So if I put this, so for example, if I say 4 is greater than 2, right? It's not going to print anything because we're negating it. It's not printing anything, right? So now we're going to talk about arrays in the C programming language. So we can put a lot of data inside of arrays. It's usually when we're dealing with huge amounts of information. So let's say we have a bunch of names or numbers. Say we have a list of 100 numbers. We don't want to create 100 different variables. This is where array can come in to help. And it's a data structure. So usually when we're thinking about a single array, we can store a bunch of information and it'd be nice and neat and organized in the program. And I'm going to show you how to create that. So a variable and an array are very similar. So variable can store, it's like a container that can store information. And this array is going to be able to store a lot of information. So if I did, for example, int, it'll hold an integer. If I do double, it'll hold a double. So let's do int, and I do my numbers. So I do open and close square brackets. They're just telling C we want to store multiple integers. So I can do equal and then open and close curly bracket. So I'm gonna do even numbers, 2, 4, 6, 8, 10. And I can type in as many numbers as I want. I can do 600, 700, however many I want, right? So I want to put a comma. This is going to separate each element. These are elements in this array. It's storing all this information. So like how a variable, we can only store one value. We can hold a lot of values here. So I'm gonna show you how we can access specific elements inside this array. So we do the %d because they're integer. What if I wanted to access specific element? I can do my numbers, and then I can do open and close square bracket to specify index. Now, if I want to access this first one, it's 0. That's gonna print out that 2 right there. Right. So when I run the program, it's gonna pull the 2. So we want to access these indexes. You would think this would be 1, 2, 3, 4, 5, but actually it counts like this on indexes: 0, 1, 2, 3, 4. Okay. So for example, this is how it would look: 1, 2, 3, 0, 1, 2, 3, 4. So if I wanted to get 10, I need to put 4 here. Let's recompile, test, right? And what if I want to change the index or one of these elements? Then I can do my numbers, whatever index I want to change. Say I want to change that 10. I do index 4, and I want to change it to 100, right? So when I print it out, it's going to print 100 now, okay? Because I changed that index to that amount, right? So I can modify. So I could tell it what I want to change this to. So what if I don't want to? What if I don't want to give it any information, right? What if I want to do an array and I want to go ahead and have it set to certain equal to certain numbers? Then I can do this, but I need to tell C how many elements that this array can hold. So I can do 15, right? Now the capacity of this array is 15. So I can do my numbers, and I can do 1, 15, and I want to print 1, it should be 15, right? But if I want to do, let's say, if I want to print 0, I haven't assigned anything there, so it's not going to print anything. So it's giving me this big number. Usually we want to give the values up front, but sometimes we need to tell C how many elements that you wanted to hold. So that way C can allocate enough memory to hold this. Now, one thing we've been using a lot in this course is strings. So look, what if we did, so this is an array of characters, right? So we could specify, how many characters we want this to hold. Now we're going to talk about functions and C. It's just a bunch of code that can specify a task, and we can access that code. We can call that function. Now we're going to talk about a switch statement. It's like a special type of if statement that allows us. Um, so now we're going to talk about switch statement. It's a special type of statement that allows us to compare one value to a bunch of different values. It allows us to catch different conditions, and that makes it really easy to compare one specific value to a lot of other ones. So I'm going to have it compare a letter grade. So if you did good or bad on the test, it'll let you know. So we're gonna do a variable that stores a grade, and then we'll have it check it. So it's gonna be a character. So we did character grade, and I'm gonna say A, and we'll do switch grade, and I'm gonna do open and close curly brackets. So I'm gonna take this variable here, and I'm gonna compare it to a bunch of different variables. And depending on the value that is equal to, we're gonna do something different. This are cases. So I'm gonna do case. Let's say A, and I'm gonna do colon. Now, in the case that grade is equal to A, then I do my code right here. It's going to say you're a rock star. And I'm going to do break. And I can copy this, right? And I'm going to say if it's a B, I'm going to say you did well, right? Now we do C. You did mediocre, right? And then if they do a D, we're going to say study harder, right? And if they made an F, drop the class. You failed, drop the class. All right. So these are a bunch of different cases. So the break statement is just telling C, it's just checking to see if the grade is equal. If we don't put the break statement, it's going to keep going. So we want to break out of this switch statement if the case is true. So we get an invalid grade, like what they put an X or a D, not a D, but a Q or something like that. We can do a default, and we'll say print f invalid grade. Yep. And I'm gonna do my semicolon. Let's see. All right, so that should be good. So let's run it. So this is what it's gonna do. We already assigned the grade A. It should say you're a rock star. All right. Let's see. Line 31. Let's see. I'm gonna put this here. All right. That looks okay. And I need to put this inside. I need to indent this. Okay. So yeah, I see what's going on. So on this line, this is the closing bracket for our main statement. So we need to do our closing bracket for our switch statement. So I need to put one here. Here. I think that should be good. Let me try to save it and recompile it. Okay, so yeah, that's good. And since we got A as the grade, it should say we're rockstar. Yep. Now let's say we didn't do good. Let's say we didn't do good. Let's say we got an F. Let's recompile this. You failed. Drop the class. Wow, that's mean. All right, now let's test and see if we do character that's invalid. Let's see if our default will work. Recompile, and it says invalid. So now we're going to talk about structs. Now it's a data structure where we can store groups of data types. It could be an integer, it could be a string, double. It's a bunch of different data types inside a data structure. So I'm gonna give you an example here. So imagine if we're storing records for a student. I can use a struct to do that. So let's do this in front of the main function. I do struct. Let's give it a name. And I do a student, and I give it a capital. A lot of times you'll be using capital when using the struct. So I'm gonna do open and close curly bracket, and we can go ahead and put different attributes of a student in here. So think about different attributes. We can say name, and let's give it an amount of characters it can hold. I'll say 40. All right, let's do major, the characters, age, and double for GPA. Yeah, so in here, as you can see, we got a bunch of attributes of a student, like their name, major, age, and GPA. So we get like a student data type. So let's go to the main method. I'll show you how we can use this. I can create an instance of this. So I can create that. I do struct. I want to do a student. I want to get a student, and I'll give it a name, student, student 0. And it's going to be to have all those attributes. So it's similar to like how an array can store a lot of information. So I can go ahead and give the student all these attributes. So let me show you how we'll assign it. So student 0, I can give them name, GPA, age. So if I do student 0.age, I could say they're 35. So they start a little late. Let's do student 0.GPA. I'm gonna do 4.0. So they're working. Say they're working hard. They're smart. What if I want to give them a name? It's gonna be a red characters. I can't just say student 0.name is equal to something. I can't do that. So I need to do a string copy function. So I need to do strcpy. I need to pass the destination. So I do student 0.name, and let's name it Donald. All right. Yeah, I can do this for the major as well. Student 0 major, and I'll say they're studying mathematics. Mathematics, and put our all right. And now I can do printf, and I can start printing out some of this information. So if I want to print out their GPA, I do this. Student 0 GPA, and when I compile this, it should print out the student's GPA. All right. It's saying I need to include that header. You know, because in order to have this method, we need to include that header, that library strings, string.h. All right. Hopefully that did what we needed it to do. Let's compile. Okay. Let's see what we got now. Okay. So yeah, it printed their GPA. Same thing. If we wanted to do like their name, we had to change that placeholder to a string. Remember? I mean, let me recompile it. Print old data. So Donald, want to print their major, same thing, but we'll just change this so that way it knows that we're looking for the major now. We'll recompile it, and then we print. And I can create multiple students. I can actually, let's just say, what if I wanted to do student 1, right? 25, 3.0, Bobby, and I could say biology, right? And right, so let's recompile and see what we got now, right? Now let's talk about while loops. We can continually execute blocks of code if it meets a certain condition. So that's what we're going to do here. It could be very, very useful if we're trying to continue to do something while something's true. I'm gonna give you some basic while loops. Okay. So first thing I want to do, I want to create an integer. So I'm going to do index equal 1. So I just do while with open and close parentheses. So up in these parentheses, we're going to specify a condition. So I'm going to put a bunch of code, and as long as it's true, it's going to keep going through this. So I do index is less than or equal to 6. I want to go ahead and what I want to do, I want to print out an integer. So I want to do index equals index plus 1. And we can do a shorthand for that. It's like index plus plus. And I want to increment it. And I want to keep looping through this code while this is less than or equal to 6. So let's see what we get. Let's recompile, and it prints 1 through 6. So it's going to look at this condition before anything else. Hey, is this index less than or equal to 6? And then it's going to execute this line of code. So it's going to print this index, and it's going to continue to increase that index by 1. So that's why we have 1, 2, 3, 4, 5, 6, because it's continuing to go through and check if it's less than or equal to 6. And I always go back to the top to check that condition. Now when it get incremented up to 6, it's going to be false. So that's why the code ends. Now it just specified a condition, right? And there's a lot of situations where you'll use while loops. Now you also want to watch out for infinite loop. That's when the condition is always true and it's never false. So if I stop incrementing this, right? uh, Let me compile here, and it just keeps going, right? And it never stops. I had to kill it manually. It's another loop that I want to go over with you. So let me go ahead and change this to 5, right? Well, let me do 8 because uh, let's see, nothing should get printed out because this is not less than 6. Now we can also do a do while loop. So what the do while loop does is it execute all of this code, and then so I'm gonna give you an example really quick. Let's see. So let me move this in this part. Yeah, index plus plus. All right, close this off, and let's see. And I could take this part out. This what we talked about earlier. All right. And I want to do a return 0 so I can exit meeting those conditions. All right, let's recompile. And it prints out 8. So because we're using a do while loop, it's doing whatever inside that loop before they check the condition. Now, sometimes it'll come in handy, sometimes it won't. It's just good to know about both. Anytime you don't want it to check this condition first, you want to do. I'm going to also talk about a for loop here in a moment. So for loop in C is used to index a variable. It'll tell us what iteration um, that we have. We can loop through an array of items. So let me go ahead and change this, and we'll do a different example. Let's do int I. Let's go ahead and initialize this to 1. We'll make it equal to 1, and we'll say while I is less than 4, we're gonna have it print. Make sure to indent. We'll have it print, and we'll do the placeholder for integer I. and then we're gonna do I plus plus shorthand. That's gonna continue to increment, right? So, and we're gonna say y is less than or equal to. Okay. So, all right. So it goes 1, 2, 3, 4, right? And I could put this on a new line if I did this and recompile. So the first time it goes through this loop, it say, hey, is 1 less than or equal to 4? It is. So it prints 1. Then it adds 1 to it. Is 2 less than or equal to 4? It is. It prints 2. Is 3 less than or equal to 4? It is. And then etc. Right? So so this I tells us what iteration that we're on. So so we went through it 4 times. It's very useful when we're looping. Sometimes you're going to want to know what iteration of a loop that you're in. So I can specify a condition, and a lot of times if you got a variable like I, which is the variable here, you may want to know what iteration that you're on. It's called, we can do a for loop that take all this code and put it through a single loop. So I'm gonna show you how we can create one. I'm gonna say for open and close parentheses, open and open close curly bracket. So this is gonna specify if we can keep looping through. So we're gonna have 3 different things. For the for loop, we're gonna have our variable, and we have our variable here, right? I can say I'm gonna say int I, and I'm gonna say I equal to 1. I want to next include my looping condition. So I'm gonna say I is less than equal to 4, and I'm gonna increment. So we'll do the same thing, I plus plus. Initialize the variable, make it 1. I'm gonna give it a condition, and we're gonna do the increments, right? I can also do minus minus, and I can do +2, but we'll do plus plus just to be simple. And I could take all this code and condense it into here. I could do all this inside of the for loop, and I could take this and it's doing the exact same thing as we've seen here. So I can actually take this out, right? Let me bring this up really quick, and let's save it and recompile it. Fingers crossed, it's gonna do the same thing. See, it goes one, two, three, 4. It's the same exact program. That's why for loops are great. We can take that index variable and we can go through those iterations. So what if we have an array? All right, so we create an array here. Let's see. I'm going to do int my numbers, and you know I like even numbers, so I'm going to do 2, 4, 6, 8, 10. All right, and I can loop through all of these. So we have 5 elements in here. I'm gonna say I equals 0, and that's because array indexes start at 0. If I want to access one, I could say my numbers 0, and it's gonna equal 2. Okay, so I'm gonna say it's less than 6, and I'm gonna print out my numbers, and I'm gonna print out. So I'm gonna do I. So Let me save this one. All right, so it goes through each one. Let me change this to 5. Right, and it's like the basic of working with for loops. They're very convenient. That way, you can loop through different items. So now I'm going to talk about two-dimensional arrays. I'm also going to talk about another type of loop as well. So if we want to create a 2D array, this is what we'll do. So I'm going to do int nums. If we want to do a two-dimensional, we'll have two open and closed square brackets. This represents the width, this represents the height. So each element inside of the array has elements inside of it. So we're going to make it equal to open, close, curly bracket. With a 2D array, we're gonna create arrays inside of here. So for example, what if I did 1, 2, or 1 and 3, the first element, and I'm gonna do comma, and let's do another one, 2, 4. This is the first element, and then inside that element has two arrays, and it has two elements inside of this one. It's an array within an array. And let's do 4, 5. So we have 3 elements, and each one have 2 inside of it. So I'm gonna show you how we can get this printed out here. So we would do, let's see, print f, and like we're doing integers, so we're gonna do our placeholder there. So that d, and let's say nums. And what if we want to do this one? This would be 0, 1, 2. So I do 0, 0, 0. All right, so let's recompile this, and it gives that 1. And what if we do 1, 1? And anyone can guess what number it's going to give us? If you say 4, that's right. And that's because 0, then 1, and then it's 0, then that's 1, right? Now, if I want to declare two variables, I could do something even more simple. I could do I, X, and Z. That's declaring two variables right there. So I'm going to show you how we can use a nested for loop to print out values in this. So let's do, like I was saying, int X, Z, and we'll do for I equals 0 and I less than 3. That's how many elements are in this array. And inside of this, I want to do another loop. I'm going to say for Z, well, let me change this to X because I got X as the values here. I'm going to do another for loop. So Z is equal to 0. Initialize that. And Z is less than 2. And Z, and then we'll better do the same thing. Z plus plus. And I should be able to print out all the elements in this array. And let's do nums x and z. Yep. So gotta make sure syntax is correct. So let me go ahead and do this. Clear screen really quick, compile, and we'll test it. So what you see here is we're getting the entire 2D array printed out. So we're going 1, 3, 2, 4, 4, 5. So what I could do as well, instead of running it together like this, I could, yeah, let me take this line off. Let's do print F, and let's put them on a new line like that. All right, and let's recompile. See what we get. So now 1, 3, 2, 4, 4, 5. Okay, so it's not printing like it was with the extra characters since we removed that. So that's an example of two-dimensional arrays and nested for loops. Okay, now we're going to talk about accessing memory addresses in C, and it's a couple of different ways we can do this. So we want to keep track and maintain a bunch of pieces of information. So let me do it. Integer age 75. Let's do a double GPA 2.0, and we'll do a character grade, and we'll call it D. So when I give when I give when I initialize these variables and I assign it 75, it's going to get stored in memory. Now you might hear memory like random access memory. How much RAM do you have in your computer? That is what it's referring to. Memory space there. Now memory is what it's gonna use when running programs. Okay, so it's gonna use that memory in order to store and keep track of these variables. So it stores these values at a specific memory location. So it takes this 2.0 and this D, and it stores these different memory addresses. So I gave these descriptive names. So I can modify these. I can print them out. So I can access this by the name, like refer to the grade, refer to GPA, refer to age, and this is stored in a physical memory. Now it need to access when it accesses this, it's gonna refer to that specific memory address. Now when C wants to refer to it, it's gonna use its memory address, right? So, and C needs to access them to use them. I'm gonna show you how we can print out that address and access that address, so you can understand what memory is. Okay, so printf. I need to use a percent sign and P if I need to print out a memory address. This stands for pointer. So I'm going to talk about name of the variable. So I want to do age. I'm going to do ampersand. So now we should be able to print out a memory address where that's stored. So let me go ahead and save it. Recompile. Oh yeah, I got to do single quotes. Okay. Yeah, C is very picky. So it gives this hexadecimal value here. So this is the physical memory address where it's stored for uh for age, because that's what we're looking for here. So I can really print out all of these as well, you know. So I could do, for example, let's say and GPA and grade, right? We got to use that ampersand. So let's see, do age. I'll do GPA. Do percent sign pointer and grade. All right. All right. All right. So let's see what we get when we compile this. Hopefully we get the memory addresses of all of them. Yeah, we do. So we're able to see what memory addresses. So if we go to these memory addresses here, it's going to store the value inside of the age variable. So all of these variable addresses are stored at different memory addresses. These are what it use, right? Yeah. So I'm gonna talk about pointers now. That's like a physical address inside of the memory. Now, so think about it like this: a pointer. Let's say, to kind of explain pointers, think about this analogy here. Think of your hometown as the memory with lots of houses being stored. Those are the variables, and addresses to locate them are the pointers. Now, you wouldn't just show your friend and say, "Hey, a picture of your house," and expect them to find it. You would give your friend the house address, the pointer, so they can easily locate it. So, with that being said, let's say, so let's say ages memory address, and let me go ahead and tell you what we can do to go ahead and access that age and address in memory. So this is gonna be where it points to it. Okay. So let me go ahead do this. %p for pointer, new line. Close that off. All right, and that looks good. So let's save it and recompile it. All right. So you get that hexadecimal number. So pointers are memory addresses. This is giving me the memory address. So this is a pointer. This is a type of data that's able to get access from a memory address. So this is a pointer, right? If I want to print out a pointer, I use that %p. And I give it the pointer right here. Just think about pointers as a type of data, and it access the memory addresses of the specific variables. So let me show you how we can work with them. So we do have the integer age variable equals 75. It's storing that value of 75. So if I do double GPA, I do 2.0, and I can do a char variable, grade, and I'm gonna say D. And I can do a pointer variable as well. So how I store integer inside of here, a double inside of here, and a character inside of here, I can store a pointer inside of a pointer variable. So when we create a pointer variable, we need a physical memory address. I could just do this off the top of my head when I create these, right? 2.0 D, I can make up a number if I need to, or a letter, right? So I don't know a physical memory address off the top of my head. What I want to do, I want to store a memory address. Um, so inside of it, I need to store that memory address of another variable. So what if I wanted to create a pointer that stores the memory address of this, right? I could say int and asterisk. I want to get this pointer variable a name. It's going to store the memory address of this. We're going to start with a lowercase p, and we're going to type the name of the variable who is storing right there, ph. And I want to set this equal to the memory address, and we can do ampersand age. Let's do the same thing for GPA. I can say double asterisk p GPA, and I can set it to the memory address. This. Now I do the same thing for this character. Asterisk a grade equal. All right. So these pointer variables are storing these assigned to these physical memory addresses. Just think about a pointer as a type of data. It just happened to be a memory address, and it just happens to be a whole number, you know. So this is a character. It's a double. That's an integer. We can also create those pointer variables. We need to store the memory addresses when we do a pointer variable. We got to store it into another address, to another memory address, right? Yeah. So that's like the basic of using pointers. So let's talk about dereferencing pointers, right? So when you dereference the pointer, you're grabbing a piece of information from there. That's all you're doing, right? So I'm gonna show you how we do that in C. So let's take out this. All right. And let Let me go ahead and do it. Have reference that pointer variable. I want to print out that pointer. So let's see what we get here. Should just get the memory address. I'm gonna show you how we can dereference it. So what's getting the physical. So the way that I'm gonna dereference the pointer is I'm gonna be going to that physical memory address and grabbing that piece of information. So the way that I dereference it, I can use an asterisk. So since I'm dereferencing it, I need to print out a number instead of a pointer. This is no longer a memory address. This would be whatever was stored. So it's going to be an integer because this pointer, because this is storing. So I'll show you. It should print out 75. So we're dereferencing the PH pointer. So that's why we get an integer now. That's basically what dereferencing is. We're just getting the value that it was pointed to. So if I take if I want to get the address of this, I could do this. And if I want to dereference it, I could do this. So it should just print out 75. And if I put an ampersand here, I should get that memory address again. So now we're going to talk about writing to files in C. So we can actually modify, change, and create new files. So now I'm going to show you how to do that. And I'll show you how to append onto files as well. So I'm going to create a file, and I'm going to store some information in there. So file in all caps is what we type out. This is creating a pointer to a physical file. And I'm going to use asterisk F pointer. It's going to stand for file pointer. Have that equal to F open, and it's a function that's going to open a file. Get a couple parameters in these parentheses. I'm going to call it workers.text. And now the next thing is going to be a file mode. So R, that means we want to read the file. W is write the file, and then A means we want to append information, like add information to a file. So I want to put a W. So this doesn't exist, right? So anytime we write a file in C, you also want to close it. So I'm going to do F close. It'll remove the file from the memory in the computer. So I'm going to close it. I want to pass in that F pointer as well. So file is like a data type, and it's creating a pointer to a physical file here. It's just a memory address. That's all a pointer is. And this pointer is going to store memory address of the workers.txt. So it's going to create this. It's going to point to the memory address of this on the computer. So I want to write some information in there. Just using this line, let me show you. It's going to be created. So if I don't specify absolute path, like for example, let's go to make directory just to show you class, right? And let's change to class. We don't see anything here. All right. So let's save this here. It's going to save it where we're at. So let's compile. Okay. Well, let me go back because I'm going to do copy test.c, and I'm going to copy it to. I'm gonna move it. Well, let's see. Copy test.c, and I want to move it to class. Trent desktop class. And let's change the class now. Is it there? Yeah, it's there. So that's the only file there, right? So ls, that's the only file there that we've seen. So let's click screen, and I'm gonna compile this. So I'm gonna save this. I'm gonna compile it here, right? And I'm gonna run it, and then I'm gonna check again and see if there's a file there. Yes, we got a workers.txt, and we got the executable that we compiled there. So I'm gonna list out just some fake employees just to show you how we can add information. So printf. Not only does this allows us to print information to the console window, it allows us to write to this file if we do printf. So I'm gonna reference the f pointer, and I'm gonna give it some information. So I can use it like I would do a normal. I'm gonna say John. I'm gonna say CO, new line, and let's do Tara, new line, and we'll make her cook. So we got John, CO. Let me do it. Let me do a comma to separate some of this stuff. Let's do cook, do a new line, and I'm gonna do Jack, comma, and I'm gonna say he is a recruiter. And let's go ahead and semicolon. All right. Let's compile. So now we're going to talk about how to read information from a file. So as you can see here, we got John in the workers.txt file. We do have this as R, so that's on read. Now we're going to do fgets. We're going to create a line variable so we can allow it to read a certain amount of characters. So we'll have it go over here to this character variable where we have 255. So we specify the amount of memory we need available. A pointer. Let's do now print f. Since we're dealing with string, we're going to do %s. Line is our variable name. All right. Let's compile this. Let's run it. If I do